All right, welcome everybody to week 3, day 1. We are going to be learning about loops today. Loops are bullet point 5 out of 6. We're almost done learning everything there is in computer science. You think I'm joking, but I'm really not. After that, it's a lot of strategies and practice and learning how to break problems down and things like that. But as far as like the basic fundamentals, yeah, we're on bullet point 5 out of 6 on week 3. So, and then after that, we got functions, and maybe towards the end of the semester, we'll learn these things called classes, which are just ways of repackaging these things. But basically, we're kind of coming to the end of computer science. So there you go. You drop out now, go get yourself a nice, high-paying job writing Hello World. Okay, so a loop. What is a loop? A loop is when you tell a computer to repeat itself. Humans hate repeating themselves, right? It's tedious and boring and repetitive, and that's why we have computers do it for us. So rather than having me tell a robot to turn its hand left and right 100 times, I was offered a job by Sony to write a program that would turn the robot hand left and right 100 times. And when I told them, what will I do for the rest of summer, because that sounds like about an hour's work, they looked at me and said, you're too well qualified for the job. Please apply for a real position. We're not going to give you the internship. And I was sad. So I don't know what they were expecting, but for somebody who knows loops, I'm just like, okay, I would just write a loop that would tell the robot hand to go left and right 100 times. I don't know what else you're expecting. So in computer science, there's a few different kinds of loops. There's 2 that I teach, and there's 2 that I don't teach. And I'll kind of go into these 2 today. So a for loop is used when you know how many times you're going to do something. For example, if I know that I want to print hello world 10 times, I will write a for loop. If I do not know how many times something will happen, for example, run the game until the user hits quit. I don't know when they're going to hit quit. It could be 1 time, it could be 100 times, it could be 1,000 times. I have no control over that. If I do that, then I would use something called a while loop. Those are the 2 main differences between these 2 when I code. Technically, these 2 things can be used sort of interchangeably, but this is my coding style that I've developed over many years, and it works actually really well. So technically, you can make one of these act like the other one of these, but mentally, here's the difference. When I know I need to do something, I need to play a sound 5 times, I write a for loop because I know how many times it's going to run. When I don't know how often something's going to happen, for example, if the user can keep entering tax data until they're done, I don't know how many they're going to type in. And for that, I use a while loop. So let's get into it. There's also things called do while loops, which I don't teach because I don't use them. I teach you what I use. I've worked as a professional programmer for over 20 years. I think I've non-ironically used do while loops maybe 2 or 3 times in 20-something years. They do come up, but their syntax is weird, and you don't technically need them. So Zybooks will go into it for you. And there's also something called a go-to loop, which Min Crowley inflicted upon the students in the noon class. Am I lagging? Do you not hear me? Is Kearney lagging? Okay. So Min Crowley showed people how to use go-to. Yeah, I don't know if I even want to show them to you guys. Towards the end of class, if you want to see what a go-to loop looks like, I'll show you. But there's a famous paper in no, don't. Yeah, but I showed the noon class, right? And if you show a noon class something, you have to show the 2:30 class, right? So there's this famous paper called "Go-To Considered Harmful," written by Edgar Dijkstra in the late '60s, and before that, and even into I would say the '70s and '80s, people were using go-to statements, which just jumps to a spot. And he wrote a paper called "Go-To Considered Harmful," and then everyone went, "Yeah, okay, you have a point." And then, yeah, not everyone, but nowadays, nobody uses go-to statements anymore. They're technically still there. If you want to see them, I'll show you to you at the end of class. But I never write them, ever. Okay. So here we go, for loops. So A for loop. Here's a syntax for a for loop. Don't type syntax, by the way, like some people in the previous class typed syntax : Don't do that. This is the code right here. Okay. There's not a lot of memorization in computer science, but this is something you have to memorize. You're gonna have to memorize this pattern over and over again, and you will be typing it over and over again until it becomes second nature for you. In my Japanese class, we'd have to memorize 40 vocabulary a week. In computer science, you have to memorize like 1. So I feel it's pretty reasonable. There's not a whole lot of memorization, but it is like learning a foreign language, and you have to just do this over and over again. Okay, so let's go through it. So how do you write a for loop? You say the word for, then open parentheses, int I equals 0, semicolon, I is less than blah, semicolon, I plus plus, close parentheses, and then a code block. And what this code means, this code right here, it means run whatever code is between these curly braces 100 times. Okay? And if I change this 100 to be a 50, it'll run this code 50 times. If I change this code to be 1,000, it'll run whatever's between the curly braces here 1,000 times. Okay? If I make it negative, it won't run at all. If I make it 0 or -10 or -100, it won't run at all. Okay? So I would like for all of you, right now, I'm going to give you like a very brief lab time, because you need to start the process of just like drilling this into your head. Okay? I want you all to go onto the server, and not inside of Simple Calculator, not inside of Algebra, just make a new document, and I want you to write a program from scratch, magic, everything, that prints hello world 5 times using this as a pattern. Okay, so write the magic, write main, and then you're going to type for int I equals 0, semicolon, I is less than 5, semicolon, I plus plus, close parentheses, see out hello world. Okay, I want to see you all do it. I'm going to pause it. I'm going to come back in like 5 minutes, and I want to have all of you screenshot your code and show me that you can make hello world, compile, run, and you should get 5 hello worlds. Okay. Starting now. All right, we'll start recording again. All of it looks pretty good. Looks pretty good indeed. I guess we can mention this one. You don't need the parentheses here. You just type return 0. Also, you don't need it at all. If you don't have return 0 at all, C++ will put it in for you in main. That's not the case for other functions, but it's a little known part of C++ that I think most people learn about. So here's the code. Using H instead of I don't know about that. That's I'm not sure that's allowed. We always use I don't know why, but we do. It's always I. And then if you've already used I, then you use J, and if you've already used J, then you use K. If you've already used K, use L. If you use L, use N. Okay, so yep, looking good. Okay. All right. So this code here will print hello world 5 times. There's the answer. I didn't have the magic and stuff like that, but I'm checking your answers over here. Looks like y'all did it. So good job. For those of you that at least posted, we got 1, 2, 3, 4. 13, 14, 15, 16. 16 people out of the 24. So 8 people in this class did not post anything. Shame. Shame. Yeah, you don't need an open brace at the end. You do need a closed brace. So if you're talking about main. So let's see here. So yeah, just like with an if statement, if you only have one line of code like this, technically you could delete both of these curly braces and it'll work fine. A lot of professors recommend always putting the curly braces no matter what. For me, I'm not really a big stickler on it either way. I tend to encourage new students to always put curly braces, like the ones in blue here. They're technically optional, though. These curly braces are required. So the one at the beginning and end of main, those are definitely required. But the ones in blue here, technically you could leave them out and the code would work just fine. When you're a new student, especially, you probably should always write them. Maybe. No. If you want to move your file up one directory, it's going to be move mv space file name space ... and that'll take the file in the current directory and toss it up one level. Okay. Here's another example. So how many times, first of all, let me ask you all, how many times is this code going to run? Okay. Don't tell me anything else. Just how many times is this loop going to run? 3. 5? No, 3. The reason why we do this code pattern is because all you have to do is just look at the number there. 3. Anytime I look at a for loop, I immediately skim it. Like I just kind of run my eye very quickly, like, bloop, okay, they're following the pattern. If I see something weird, like, they're starting at 10, or they're going down. Like if there's something weird going on, then I'll actually sit there and like use my brain cells, trying to figure out what's happening. But as long as you follow the pattern, you don't have to think about it at all. It's really nice. There's a lot of different ways you can write a for loop. You'll probably see some of them in the Xi books, like they start at 1, these less than or equal to, things like that. But once you start doing that, then you have to start counting on your fingers. Like, okay, and it just gets really messy. It's really easy this way. If you follow this pattern, for int I equals 0, I is less than blah, I plus plus, whatever blah is how many times the loop runs. Okay? Really simple. Where blah is a 0 or positive number. If you type in -10, it'll just skip all of it. Okay. So, what is this code doing? Nobody's typing. One person's typing. Caesar's typing. What is this code doing? Hi, my name is. What? My name is. Who? My name is. Chicka Chicka Slim Shitty. Thank you. Somebody got the reference. So this is going to print the chorus to My Name Is by Eminem 3 times. Okay? So I didn't have to repeat myself. I could just type it in once and then slap it into a for loop, and the for loop is just going to print these 3 lines 3 times. It's going to do a total of 9 lines of output, right? 3 times it prints 3 lines. Yeah. Right? So this is going to print a total of 9 lines. It prints these 3 lines 3 times. So it's going to go hi, what, who, hi, what, who, hi, what, who. Okay? Understand? Pretty easy. There's some semicolons here that people forget. Sometimes people put a semicolon here, and that's really bad because a semicolon is valid. C++, it just means do nothing. And so if you put a semicolon here, it would do nothing 3 times and then proceed to run this code once, and you will be very confused by it. So you just need to follow the pattern, okay? Just as long as you follow this pattern, everything's clean, everything's nice, everything's easy. You don't have to use your brain cells. It's just you look at the number there, that's how many times it runs. Okay. You forgot to put int before I equals 0? Yeah, that'll do you. Mm-hmm. And that's why I'm having you do lab time, is just to get those repetitions in. You need to do it. And unfortunately, there were 8 people that are on the stream right now that didn't post their code. So what are you doing? Like, are you just like going to Taco Bell, like when I'm doing lab time? Like you got to sit there. You got to make the code. You got to work on it. If you don't know what to do, if you don't know how to like go into insert mode in Vim or something, you need to message me, message Mincarelli, something like that. Because in the in-person class, we're walking around constantly, and we can see when somebody's stuck. Online, we've had 7 people drop from this class, and we've had none drop from the in-person class. And I'm pretty sure that's because they were just like, I don't know what to do. I don't know how to ask for help. I don't know what's going on. And just dropped, rather than admit they don't know what's happening. And in an online class, like, again, that responsibility is on you. If you don't know what's happening, you have to reach out to us. I can't telepathically view your computer. Okay. That's why I'm asking you to screenshot stuff. But if you don't screenshot stuff, then, I don't know what you're doing. Okay, so how many times is this going to run? It's going to print out some numbers. The first number it's going to print is 0, then it's going to print 1, then it's going to print 2. How many times is it going to print a number to the screen? Got a 0, got a none, got 4 zeros. A lot of zeros. People are jumping onto the hype train for 0. Got 2 people saying whatever number you input, 3 people saying whatever number you input, 4. Sorry, isn't it 1? Infinity. Got a lot of answers here. Okay. Well, we got some disagreement here. So why don't we go to the server? We'll resolve this conflict in a court of law. All right. Only court that matters. Okay. So we have here integer, was it x equals 0? It's index. So this line here makes a variable named x of type integer initialized to 0. This line here will pause and it'll wait. Usually when I'm pausing, again, I like to please enter x, just so I know what's going on, so I don't think it's frozen. Read an x, and then I'm going to do the for loop. Again, for, open parentheses, and I equals 0, semicolon. I is less than x, semicolon. I plus plus. What does I plus plus mean? What does I plus plus mean? What number does it add to I? It adds 1. Very good. Okay. And we'll get into explaining the for loop in just 1 second. I actually think that this code here is actually going to maybe explain what's going on. Okay. So, g++ main.cc, and run it. If I type in 5, it prints out 5 numbers. Okay. First time through the loop, I is 0. Next time through the loop, I is 1, then 2, then 3, then 4, and then it quits. Good job, Sally. 10 points for Gryffindor. So the reason why it runs 5 times, because I typed in 5, is because the first time through the loop, I is 0. The next time through the loop, I is 1. 0, 1, 2, 3, 4. 5 times. 0 to 4 is 5 numbers. Okay. Why does it not print 5? Because 5, when I is 5, it checks this thing here, and I'm about to explain to you what the for loop means, but 5 is not less than 5, so it quits. Okay. So this is called the half-open range pattern, and it is prevalent in computer science. You will see this pattern starting from 0, going up to 1 less than the number everywhere, especially in C++. So if you want something to happen 5 times, we count from 0 to 4, and that's 5 numbers. Okay, so let me explain what's happening here. So this code here is kind of equivalent to this. So this is option 1, and then I'm going to give you option 2. And these 2 things are going to be equivalent. This part of code here, the first thing, is like you're making a variable above the for loop. Very close to this. In fact, it used to actually do this. There's actually a slight difference nowadays, but for all intents and purposes, it makes a variable before the for loop. Okay. Then we have a while loop. And a while loop is exactly like an if statement that repeats. Okay? So, the only difference between a while loop and an if statement, right? This looks very similar, doesn't it? Is that the while, if the thing is true, it does it again. Okay? And it keeps doing it again and again until the conditional here is false. So it's an if statement that repeats. Okay? So, cout I. So this part here is this part here. Okay. So basically, if I is ever greater than or equal to x, it stops the loop. Okay. So if we type in like -10 for x, it won't run at all, right? Because 0 is greater than -10, so it'll just skip over the while loop and do nothing. And then this part here, so there's 3 parts to a for loop. The first thing creates the variable and initializes it. The second thing is the conditional. It's like in an if statement. If I is less than x, run the code. That's what that means. If I is less than x, run that code. If it's not, skip over it, keep going. Okay? And then at the very bottom of the for loop, it adds the third part here. So this code here is exactly the same as this code here. A very slight difference here. Okay? Y'all with me on this? So if we trace the flow of execution here, we start with I equal to 0, and the user has typed in 5. Is 0 less than 5? Yes or no? Is 0 less than 5? This is like an if statement, remember? It's like an if statement, except if the conditional is true, it'll do it again once it gets to the bottom. Yeah, so 0 is less than 5. So it prints out 0. Right? Then it increments I by 1. So I is now 1. Is 1 less than 5? Yes or no? I sure hope so. So then it outputs 1. Now I is 2. Is 2 less than 5? Yes, it outputs 2. I becomes 3. Is 3 less than 5? Yeah. Prints out 3. I is now 4. Is 4 less than 5? Sure is. It prints out 4. I is now 5. Now, is 5 less than 5? So it'll skip over the everything in the code block, and it will keep running. All right. So if we were to compile this code, you will see it will print 0 to 4, 0, 1, 2, 3, 4 for option 1. That's our for loop. And then you can see in our while loop version, it prints 0 to 4. Exactly the same, code. The for loop is just a little bit more compact. Okay. So like I told you earlier, a while loop and a for loop are very similar. And in fact, they can be used almost interchangeably if you want. But mentally, I use a for loop when I know how many times something's going to run. In this case, it's going to run X times. Doesn't always have to be a fixed number, like 5. In fact, it's very often not a fixed number. Right? So, does plus plus I work as well? Sure does, because I plus plus and plus plus I are exactly the same unless you have a compound statement in which multiple things are happening. In which case, I feel very nervous about, like, you can do things like cout plus plus x, x plus plus. I highly recommend not writing code this way. When you're an advanced student, even still, no. This is maybe, but no. Especially where you are right now. Don't do that. Yeah, it's undefined behavior, right? So if I type in 5 here, do you know the difference between plus plus x and x plus plus? Plus plus x increments x before this line of code runs. X plus plus increments x after the line of code runs. What happens if there are 2 on the same line? Who knows? Nobody knows. It's undefined behavior. So this code here is actually garbage code. It could print out 5 or 6 or 7. Who knows? So if I type in 5 here, it's probably going to increment this to be 6, and then that'll probably be 6 also. And then x will probably be 7 afterwards, but it doesn't have to be. It's technically undefined behavior due to code point or sequence point ambiguousness. All right, type in 5. Yeah, so we got 6 and 6 and 7 as expected. But don't do this. Yeah, if you're ever writing code where Like the compiler's going like, I don't know, man. Like, I don't know. I don't know what's going on here. Like if you're confusing the compiler, that's a sign your code's not good, right? So don't write code like this. Okay, there is a difference. The plus plus x increments the x before the line of code. X plus plus increments after the line of code. That's why you get 6. Like I put a 5 in here. This turns it into a 6. It prints out 6. It prints out 6. And then after it's all done, it increments it to 7. That's why we're getting that. Okay? Don't write code like that. It's bad. Okay. Rant off. So, what would happen if I type in -10? The very first time is 0 less than -10. No. And so that's false, and it skips down to here, and it keeps going. So if I type in -10, it just doesn't do anything at all. Okay. Any questions about this? In the previous class, students were like, well, why didn't you start at 1 and go like to lesser than or equal to x? And the answer is, if you ever break from the pattern, I'm no longer confident I know how many times it runs. So if you do something like this, I mean, for something like this, I get, I could probably figure it out. But like, people will do like 100 and is greater than x, minus. Like, how many times is this going to run if you type in 5? 95 times? 94 times? 96 times? Do you know? You want to put $100 down on it? How many times is it going to run? Anyone? Yeah. This is why you follow the pattern, right? Like, if you need to count down from like 100 to, whatever. Actually, I'm curious. Like, type in 5 here. Ran. Take this out. So it goes from 6 to 100. So that's 95. So, I would not write code this way, especially when you're a beginner. Just don't write code this way. Always follow the pattern, okay? If you always follow the pattern, you won't have off by 1 errors. You won't have to sit there and run the code and count and be like, okay, all right, that looks about right. One of the biggest problems in computer science is the off by 1 error, where you go 1 too far or you go 1 too few, right? It's also known as the fence post problem, because if you buy like 3 sections of fence, you have to buy 4 fence posts, right? It's 1 fence post, 2 fence post, 3 fence post, right? So you have a total of 4 fence posts for 3 sections of fence. Or if you start work on January 5th and you finish on January 8th, that's 4 days of work, not 3. The 5th, the 6th, the 7th, and the 8th. You start on the 5th and end on the 8th, that's 4 days of work, not 3. Very common problem in real life, very common problem in computer science. And one of the best ways of negating the off by 1 errors, at least in this context, is just follow the pattern. If you follow this pattern, you know every time exactly how many times the loop's going to run. Okay? You can do fancy stuff if you want. Like if you wanted to count down from like 100 to like 0 or whatever, like you're doing like 100 bottles of beer on the wall, And this is a community college, so it's non-alcoholic beer. Like that. You could start at 100 and go down, but watch this. This is how I would do it. So I always know exactly how many times the thing's going to work, and then I make the numbers work out using the powers of algebra. Do you see this? So the first time through the loop, how many bottles of beer are on the wall? Non-alcoholic beer. The first time the loop runs, I is 0, right? So it's going to print out 100, right? 100 bottles of beer on the wall. Next time through the loop, I is 1. So how many bottles of beer are there on the wall? 99. Understand? So that is how I would... oh, I needed a space in there. Yeah, and then it finishes with 1 bottle of beer on the wall. Yep. Probably I should... make this proper grammar, right? So if I is greater than... let's see, if 100 minus I is greater than or equal to 2, then it's a plural. Right? If you have 2 or more bottles of beer on the wall, it's a plural. Otherwise, it's going to be 1 bottle of beer on the wall, right? The beauty of the English language is you actually have to write code to handle plurals properly. Or you do this. But yeah, it's actually one of those annoying things in code to actually care about. Okay, so we start off with 100 bottles of beer on the wall, and when we finish, we have 1 bottle of beer on the wall. No plural. Okay. For loops with an if statement are a very strong combo, indeed. Indeed they are. Okay, so that's the for loop. Pretty straightforward, I think. The only tricky bit is that new students always have trouble remembering where the semicolons go. They try to stick a semicolon here or here where they don't belong. Notice there's exactly 2 semicolons in this entire line. 1 is here, 1 is here. And the reason why they're split up like that is because it's literally that line and that line separated from that line. Okay, so that's why they have a semicolon in the middle. It's a very weird syntax. It only really appears here in for loops. And the for and the smooth parentheses, yeah, just you're gonna have to grind this. Okay, there's not a lot of memorization in computer science, but this is something you have to memorize. You just have to write it over and over again. Okay. Now, let's move on to the while loop. The while loop, like I said, I use this when I don't know how many times something is going to run. For example, if I did something like this, while loop, and sum equals 0, I would write while true. Okay, so I'm going to be asking the user, cout, please enter your tax receipts. Okay, and I'm going to sit there and cn into x. Oh, I already got x, I don't need to redeclare it. Sum plus equals x, cout, the sum is sum. And this code will run forever. While true is never false, all right? So let me show you this code running, and it's not great because it's an infinite loop, but let me just show you how this works. Do you understand? So this is like an if statement, right? You know how I said a while loop is like an if statement? Because it literally is, right? So if I had if true is always going to run this code, right? But if only runs it one time. If you change the if to a while, like that, when it gets to the bottom, it goes up to the top and it checks the conditional again. And if the conditional is still true, which, spoiler alert, it always will be, it will do it again and again and again and again. So let me show you what this looks like, and then I will show you how to quit out of an infinite loop, because that's an important skill to know. So please enter your tax receipts. $1, $1, $1, $1, $5, $5, $5, $5, $2, $3, $10. See how this works? It just goes infinitely. I don't know in advance like how many tax receipts the user has. They just keep typing until forever, because it will never end. Now, we're stuck in an infinite loop. No matter what we type here, it's going to run forever. And so to get out of an infinite loop like I just did there, you hit Control C. Okay? Control C. If you fall into an infinite loop, and you will, Control C is for cancel. It quits your program. Okay? All right. So how do we quit normally? Well, let's do something like this. Please enter your tax receipts 0 to quit. So how do you get out? There is something called break. And this pattern is very, very powerful. So you say while true, you read in some data or something like that, and then if you hit something like this, like if they type in 0, then we're done. And we break. And what break does is it jumps into the loop and keeps going. Okay? So this is how you escape from the infinite loop without, needing to Control-C it, right? So, please enter X, 10, tax receipts, $20, $30, $40, $50, $10, 0. And quotes. It ends the loop. And after the loop, there's nothing else down here. So, there you go. Make sense? What do you think? So I don't know how many tax receipts the person's going to type in, so I can't really do a for loop, right? I can't say, well, enter 10 tax receipts, because I don't know. Like, they're just going to keep going until they hit 0. And so the while loop is appropriate here. Do you have any questions about this? Pretty straightforward. Silence on the Discord channel. All right. All right, let me give you a sample password, that kinds of thing. Please enter your password. All right. String S, scan into S. If S is not equal, if S, double equals, enter 2, then break. Okay. So if they get the password correct, we end the infinite loop. If they don't, then we're going to see out wrong password, try again. And they can just keep guessing over and over again until they get it correct. All right. And then once they get it correct, it'll break and it'll come down here and say access granted. You are in the mainframe. I can add a beep character here. I have beeps disabled, but if you want, there is such a thing called beep in the ASCII table, which is the standard character encoding set for America, which is also kind of standard for the world because we sort of invented the internet. There's actually a special character for beeping, and that's because back in the teletype days, it was like a remote typewriter. So you type something on the teletype, and they would see it over in New York, and they could type something back to you, and you could see it. It's like instant messaging, 1970s style. One of the characters you could send is the bell character, Control-G. And that actually would have a little hammer hit a little bell on the teletype, so you'd be like, yo, are you there? Ding, 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 ding. You actually ping them, and then they would walk over and like, oh, somebody's trying to talk to me. So it's still, this is in Unicode, all right? Unicode is still using ASCII, UTF-8, that is. So, can you put Unicode into strings? Yeah, sure, of course, why not? So we can do Ninja Cat. There we go. Ninja Cat, please enter your password. Please enter. Sorry. Please enter your password. There you go, Ninja Cat. Right. Please enter your password. 10. Wrong password. Hello. Infinite loop. What just happened here? Oh, because I'm reading into X. That should be an S. Thank you. All right. Please enter the next one. Okay. Please enter your password. Cool. All right. And you just keep typing in the wrong password over and over again. But once I type in Hunter 2, then it says access granted, you're in the mainframe. So, yeah, you can put beep characters in. You enter a beep character via Control-V, Control-G. And then you can embed a beep into a string, because that's actually part of the ASCII and Unicode standard is a beep. You can put Unicode in there if you want. Unicode can be added to your strings. Go and have some fun with it using Windows period. That's like your cup of tea. Do cout rocket ship to the moon. And then you can have some diamond hands for all your crypto trading losses. Okay. Okay, so what I want for you to do for lab time, you're being told wrong password, try again on every possible tick. Control C. Remember, Control C is how you quit out of an infinite loop. And remember, if you were to cn into x, which is an integer, if you try typing squirrel when it's expecting an integer, it fails and it keeps failing forever. And it will go into an infinite loop, printing out wrong password on every tick. Okay? So you need to Control C out of that and change that to be inputting a string instead of an integer like I did a second ago. Okay? So for your lab time, and you will have 15 minutes of lab time, and then I will come back and give you the answer. I would like for you to make a guessing game. Okay? So for lab time, make a guessing game. The user enters a number from 1 to 100. You should probably, like, I don't know, like, secretly pick the right number, like 42. Right. The user enters a number from 1 to 100. If statement. If they typed too high, tell them too high. If they typed too low, tell them too low. If they got it right, tell them they won and break out of the loop. So, do we have, before you begin, should we use a for loop here or a while loop? Did I give you a maximum number of guesses? Yes or no? Right? I didn't. I didn't give you any maximum number of guesses. And so how many times, you tell me, how many times will the user guess a number before they get it correct? Do you know? And they could feasibly just keep typing 5 over and over again, right? So you don't know. If you don't know how many times they're going to guess, while loop. Okay? So you all got that. So this should be a while loop, not a for loop. If I told you, there's a maximum of like 5 attempts, then that would be a for loop, not a while loop. Does that like cognitively make sense to you all? That's how I decide if I'm going to be doing for loop or while loop. If I know you get 5 guesses, for loop. Keep guessing till you get it right, while loop. So, yeah, it's going to be very close to this code here. I'm actually going to move this up maybe. I'll put this up top so that you can see it. All right. Don't need you, don't need you. Not using you. Okay. That is good. This code here is going to be pretty close to the guessing game. Right now my code is just being like, yeah, did you get it right? Did you get it wrong? But you're going to change it so that instead of it just being right, instead of just double equals, you're going to check for less than. If the guess is less than the right number, you say it's too low. You're going to check for greater than, and you're going to check for equals. Okay? Or maybe you don't check for equals because you might use an if, else, maybe. I don't know. It's up to you. I'm not going to tell you what to do. So you have until 3:35 to work on this, maybe 3:38. So I'll give you 15 minutes to work on this. And then I will come back and type in the answer for you. Okay? And you can see what the guessing game would look like when done by a professional professor. Pausing the recording now. All right, go ahead and post your thingies. And I'm going to show you the answer. See out, guess. And I'll slap this into a while true loop because we don't know how many times they're going to be doing it. Int answer is equal to 42. Okay. Int guess is equal to 0. Send a guess. If guess is less than answer, then see out you guessed too low. Else if guess is greater than answer, guess too high. Else well, there's only one possibility, right? So if this is false and this is false, then well, by process of elimination, this must be true. Okay, and remember, you don't put anything on an else. Like there's nothing. Like people will put things here. No, just if both of these are false, then the else will trigger. See out. Let's just do this. Break. And then down here, see out. Congrats, you got it right. One too low. 100 too high. Too low. Too high. Too high. Too low. 42. Congrats, you got it right. And it breaks out of the loop. When you hit a break, it jumps down to here and keeps going. So if it goes crazy when you punch in a string, that's because, remember how we talked about like trying to fit a squirrel into an integer? Boom, infinite loop, right? What happens is that the CN here falls into a fail state, and the CN automatically returns, and then it's going to probably leave guess at 0. So we need to do something like this, right? If not CN, CN, you entered a non-integer, and just quit. If you want for it to reprompt and retry and clear the error code and things like that, that's a little bit more advanced. But for now, just say nope and quit. Okay. My read library actually will do that for you, but for now, just that's all you need to worry about. And that is our lecture for today. That's our first introduction to loops. We will continue this discussion on Wednesday. Remember, your Zybooks is due on Wednesday. Most people in the class have not done the Zybooks yet. I checked on the status today. About a third of the students haven't even started. It's not good because it's twice as long as the previous one. And this is not a class where you don't want to do the textbook reading. You can probably get away with that in most classes. In this class, the textbook reading gives you the hours of practice you need to get good. If you don't, you're just gonna, it's like trying to do Japanese when you never practice. You never do Japanese. Like your Japanese will just be terrible. It's just like that in computer science. Zybooks gives you the necessary repetitions you need to get good. And so I have all the stats to show that to you, that when students don't do it, some of them will pass, and those people are the ones that have done computer science before. But for people that have never done computer science before, the shortest route to failure is just to not do the Zybooks. So I know they're out of key codes somehow at the bookstore. I don't know how you run out of digital books, but they did. So make sure you just sign up for the free 2-week trial on Zybooks so you can get that in. Yeah, so basically, make sure you get the Zybooks in by Wednesday, and then Simple Calculator is due on Friday. And I will see you guys on Wednesday. Peace out. Be good.